platforms, this is like to design logistic networks for logistic support for remote farmers, for instance. This is the kind of stuff you want to detect. But this is expensive. You can't use that. So this is out of the question. Well, what you do have is that. It's lower. So this is a machine learning output. This is what the model thinks the HiRES looks like because it has combined a lot of different things that are real. They're actually real data. But it combines them in a certain way that now it can recreate the road, it can recreate the boundaries. This is pretty cool. I was impressed by that. Another example. Maybe you're interested in finding out how much crop yield you get out of each farm. So this is called pivot irrigation. It's like a big circle kind of farm. And remember, each one of those pixels is 100 meters. So these pivot irrigations are massive. You might be interested in saying, well, I want to see how much yield they have produced. You can't really see that from the low res. You can only see on, off. But you can't really estimate. So one way to do a first order approximation is to do this multi-frame super resolution thing. And this is what you get. This is the recovered, the reconstructed high result image. Not bad, right? I'm going to skip those examples, but the way we do it, this is what the model looks like. It takes as input all these low-res pictures. This is the input, this is the ideal output. And the way it processes that, I'm going to skip a lot of steps here. It does something which we call fusion in machine learning. So fusion is a technical term. It means you turn your input in some kind of representation, something which is meaningful only to the computer, but it's only meaningful for the task at hand. So the raw image you get, there's a lot of stuff that you need, but there's also a lot of stuff that you don't need. They're useless for your prediction problem. So think of these green blocks as only what is the essence, what is useful for a prediction problem. And then you teach the computer how to take these representations and combine them into one. So now basically you have a framework where you can combine as many low-res images as you have into one final representation, and then you zoom it, and you combine it into the final output that you get all the way to the right. This is multi-frame super resolution, and this is a model that we call HiResNet. And it was the winner in a competition from the European Space Agency back in June. Good. Okay, so I'm not going to cover fusion here. Fusion if you have a physics background, if you like physics, fusion means a very specific thing. It also means other things. Maybe you're interested in other areas as well. But in this sense, this is what we mean by fusion. It's all about combining these representations in meaningful ways that make sense for a prediction task at hand. I'm going to skip that one, skip that one, skip that one. Okay. Okay. So the same framework also applies for heliophysics. What's heliophysics? Any clues? What's heliophysics? Yeah. Yeah, it's physics of the sun, exactly. So heliophysicists care about solar weather. You probably haven't heard of solar weather before. Solar weather is basically all these particles that fall into the Earth. They create beautiful things like the aurora, but they also create negative effects like GPS disruptions. So if you're trying to find on Fido on a Sunday morning and you can't find it, it's probably because of the sun, right? Okay, so what are years of data, magnetograms like that? Some of them are quite old, like all the way back to 40 years. They're very low resolution, and then the question is, how can you turn that into higher resolution? Same problem that I described on the Earth. Now, this is using the same idea that I described. You can go from this all the way to that. And this is what the ground truth high resolution of that area and that time looks that corresponds to this thing. So not a bad recovery. So now heliophysicists have a way to kind of uniformize all of the measurements that they have, all of the magnetograms, all those old ones, and make them look very similar to the new ones that they have from more recent instruments. Yeah, so we can apply this idea also to Darfur, as I said. you can take a bunch of lower snapshots, and because higher snapshots are very expensive, you can combine all those low-res images, recreate the super resolution, and then predict destruction or human presence. And that saves a lot of money to these organizations like Amnesty International or Human Rights Watch, that's another big one. Or if you care about environmental applications, maybe you're Greenpeace, you're interested in measuring the amount of deforestation that is happening on a weekly basis, right? So yeah, that's the end of my talk. That's the big picture here. If you care to learn more about the vision that my team has about super resolution, go to this article. It's called Google Computer Enhance Please. So it's a very high-level article. It just lays out the vision of our team. And yeah, that's the end of my talk. Thank you so much for your patience.
Any questions? Any questions at all? Any questions from anyone?
Hello?
Is there some at the back?
Someone at the back. Levi's.
What limits the quality of photos you can get up to, assuming you can have thousands of low-resolution photos?
Well, if you have thousands of low-resolution photos of the same area, then you can zoom in pretty deep, yeah. In practice, that's not going to happen. Let's say you have 32 images. So I'm just going to give you a rough example. Let's say you want to do a zoom of 3. So that means that you have 3 times the width and 3 times the height. That means you need then, you're basically doing...
If you have false positives, especially when human rights things, you don't falsely accuse of country.
Yeah. So the question is, because it wasn't too loud, the question is how can you deal with the false positives, right? So that's true, that's a common problem with classification. What is important for of what's going on out there is not, that means that it's not gonna